Chapter 16, Chemical Reactions. All right, everyone, today we're going to talk about something really exciting, chemical reactions, especially how fuels burn to give us energy. Think about when you light a candle or burn wood in a campfire. That's called combustion, a type of chemical reaction where something reacts with oxygen and releases energy in the form of heat. This chapter helps us understand what really happens when fuel burns and why it's super important for cars, airplanes, and even power plants. Let's start with fuels. Fuels are materials that burn to give us heat. Most fuels are made of carbon and hydrogen, and they come in different forms like coal, gasoline, diesel, or natural gas. Each one burns a little differently, like how some candies melt quickly while others take longer. When we burn fuels, we usually burn them in the air, which contains oxygen. But did you know? Air is not just oxygen. It's about 21% oxygen and 79% nitrogen. And when we burn things, nitrogen mostly just tags along without reacting. When something burns, the stuff before the fire is called reactants, and the stuff after burning is called products. For example, when you burn carbon with oxygen, you get carbon dioxide as the product. During burning, the number of atoms stays the same. They just rearrange to make new things. Like if you have 8 pieces of Lego and make a house, or take them apart and make a car, you still have 8 pieces. We also talk about something called the air-fuel ratio. It's like making a cake, where you need the right amount of flour and eggs. If you use too little air, some fuel doesn't burn properly and makes smoke. If you use too much air, you waste air and don't get much extra benefit. Engineers used just the right amount called stoichiometric air for clean burning. Sometimes they use extra air to make sure everything burns fully. Next, we learn how to check if burning was perfect. We look at the gases that come out, like carbon dioxide, water vapor, and sometimes carbon monoxide or leftover oxygen. There's a machine called an ORSAT analyzer that helps check how much of each gas is there, kind of like counting candies after a game. We also discover something called enthalpy of reaction, which is like counting how much energy is gained or lost when burning happens. If it releases heat, we get negative values because energy leaves the system. The amount of energy you get depends on how the product ends up, whether the water formed stays as steam or becomes liquid. This is why there's a higher heating value, HHV, when water becomes liquid, and a lower heating value, LHV, when it stays vapor. Finally, we use energy balance to make sure everything adds up. Engineers calculate how much energy comes from fuel, how much goes into the air, how much is useful, and how much is wasted. We even talk about things like flame temperature, which is how hot the burning can get if no energy is lost. This helps design engines that don't overheat and work efficiently. So, next time you see fire or ride in a car, remember there's a lot of fun science behind how fuels burn, how air helps, and how we count the energy to make sure nothing is wasted. That's the magic of chemical reactions in engineering, turning fuel into power. Next time, we'll look deeper into how to make these processes even better and cleaner.